Okay, today's lesson is on experimental and theoretical probability. Our target is I can find experimental and theoretical probabilities and also make predictions. So our first vocabulary word, with today's notes we're going to be skipping around on your guided notes. This one is in the top left-hand corner of your notes, and your theoretical probability is what should happen. It's the ratio of the number of ways an event can happen to the total number of outcomes. In your notes, you have a spot that says P of an event. That little p means probability, and then your event would go there. And you can write your fraction as your favorable outcomes over your possible outcomes. We are going to move on to our first example, and this is on the top right-hand side of your guided notes. Example 1, you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? We want our favorable outcomes over our total. How many vowels do we have?
4.
3 out of how many total letters? 7. So our probability is 3 over 7, or 3/7. If we wanted our probability written as a decimal, how could we change this to a decimal? To a decimal. You can round to the nearest 10. So 3 divided by 7 gives us 0. Round to the nearest hundredth. 4, 3, and what would that be as a percent? 43%. So 0.428, and it keeps going, round to the nearest hundredth, that bumps up to 0.43. For our next question, I'm going to have you move on to the on your own and try number 1 of the on your own. If you read through this, the letters in the word Jackson are placed in a hat. You randomly choose a letter from the hat. What is the theoretical probability of choosing a vowel? In Jackson, how many vowels do we have? 2 out of how many total letters? 7. How do we change 2 sevens to
By 7 and round to the nearest 10.
would be hundredths?
That's what I said. Don't even try and prove me.
0. You get 2,857. It's going to round to 29. And what's our percent? 29%. So remember, your probability can be represented as a fraction, decimal, or a percent. Okay, we are moving back to the examples, which are at the top right of your notes, and we are back at example 2. For example 2, the theoretical probability that you spin an odd number on a spinner is 0.6. The spinner has 10 sections. How many have odd numbers? So if we look at this, what is our probability that you land on an odd number? 0.6 or 60%. We can set that equal to our fraction. We know there's a total of how many outcomes or sections?
Come on. Go to the
10, and then we don't know how many of them are odd, so you can set up a proportion. How do we write 0.6 as a fraction if you wanted to multiply?
What and
Over 1. Example 2, or you can write it as 6/10. When you cross multiply, 1 times x gives us x, and what is 0.6 times 10? 6. So we get that x equals 6. We know that there will be 6 odd numbers. Your 6 sections have odd numbers. You might have been able to do that without any work if you know that 0.6 is 6/10 or 6 out of 10. Back in your notes section, which is the top left-hand corner, we are filling in our next vocabulary word, and that is experimental probability. Experimental probability is what actually happened. It's probability that is based on repeated trials of an experiment, and your probability of the event is the number of times the event occurs over the total number of trials. So when you find example 3, it's underneath our definition for experimental probability. Our first example for experimental probability is 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? So how many times did the event occur? How many junk emails? We got 13 out of how many total emails? 20. How would we change this to a decimal?
13 divided by 20 and not to the nearest 100.
13 divided by 20, what do we get? 0.65. And what would that be as a percent?
65%.
65%.
So that's likely?
Yeah.
Yeah.
Okay, I want you to move on to the on your own. Number 2 on the on your own section. I want you to go ahead and try this one. I'll give you a little bit of time before we go over it. For this example, 15 out of 25 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? 15 out of 25. Can we simplify this fraction?
Yes.
What can we divide by 5?
5.
5. 15 divided by 5 is 3, and we get 3 over 5. How do you write 3/5 as a decimal?
0.60.
And what is our percent?
60%.
60%. Okay, so we are back at example 4. It's the one with our chart for rolling a number cube. And the bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? How does this compare with the theoretical probability of rolling an odd number? So if we're finding our experimental probability, we know that we rolled the number cube 50 times, so that's going to be our denominator. Of those 50 times, how many times did we roll an odd number? What are our odd numbers? 1, 3, and 5. How many times did we roll a 1? 10. How many times did we roll a 3? How many times did we roll a 5? 8. When you add 10 plus 8 plus 8, what do you get? 26. So 26 is the number of times that it actually happened. 26 50ths. Can we simplify this? If you divide by 2, 26 divided by 2 is 13. 50 divided by 2 is 25. 13 25ths as a decimal. 13 divided by 25 gives us 0.52. And that would be 52%. Now they want us to know, how does this compare with the theoretical probability? Theoretically, how many odd numbers do we have? 3 out of how many total? 6. What would that be?
50.
That would be 0.5 or 50%. So how does it compare? It's pretty close to what should actually happen. It's a little bit off. The more times you conduct your experiment, or the greater your number of trials, the closer you should be to your theoretical probability. So the next part you're looking at in your notes is underneath example 3. Underneath example 3, it says this right here. Experimental and theoretical probabilities can be used to make predictions. When we make predictions, we set up our two fractions, set them equal to each other, and cross multiply. So we're setting up a proportion, and our proportion is, on this side we have our probability, probability is frequency over total, and we set that equal to our predicted outcome, the estimate over the estimated total. So go ahead and copy in the proportion into your notes. Example 5. So find example 5 in your notes. It's right below where you just wrote your proportion. And we are going to make a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? They're letting us know that April has 30 days. We're going to set up a proportion. How many rainy days did we have? 2 out of how many days? 12. And we want to predict how many rainy days we expect in April if it has a total of 30 days. Would 30 go in the numerator or the denominator? The denominator, and we can fill in our numerator with an X. We're not sure how many rainy days we will have in April. To solve this, we are going to cross multiply. 2 times 30 gives us 60, and 12 times x gives us 12x. We now have a one-step equation. 60 equals 12x. How do we get x by itself? Divide by 12. This cancels. We're left with x equals 60 divided by 12, which is 5. So we would expect 5 rainy days in April. You guys have about 3 more questions on your own questions. I'm going to have you go ahead and work through those 3 questions on your own.